now we're going to look at graphing logarithmic functions. And this can get a little tricky, especially if you're going to use the calculator, but we'll look at that in a second. But let's first talk about how to graph it by hand. So instead of using f and f of x to determine some values here, because it might not be obvious when you put a number in for x what you're going to get out for f of x. What we can do is think about it as an inverse function. We know that the inverse function to a log is 2 to the x, the base to the x power. So since this is the inverse, let's graph x and the inverse of x. So let's try numbers like -3, -2, -1, 0, 1, 2, and 3. So we know that 2 to the 0th power is 1, 2 to the first power is 2, 2 squared is 4, 2 to the third is 8, and then the 2 to the negative first is negative, or I'm sorry, it's positive 1/2. Let's see. Try that again. Positive 1/2. And then we have 1/4 and 1/8 for the negative third power. So now what we can do to graph this is essentially just switch these around. Since we graph the inverse function, we know that for f of x, these will be my f of x values if I make these my x values. So let's get rid of that. So now I have enough information to graph it. So let's check the graph here. As you can see, when I look at my x value, where I have 8, I should have 3, and that appears to be the case. Where I have 4, I should have an f of x value of 2, which seems to be the case. At x equals 2, I should have a value of 1, which that appears to be 1. And when x equals 1, which is right here, I should cross the x-axis, which I do. And you can see we kind of have an asymptote, the vertical asymptote at x equals 0, because we have to have positive values. So looking back at everything I need to find here, let me see if I can shift the graph up a little bit so we can take a look at it. So we want to find its domain. Domain appears to be everything greater than 0. So let me write that out. Domain appears to be where x is greater than 0. The range appears to be all the way from negative infinity up to positive infinity. And if I want to stay consistent, I should really write this domain as 0 to infinity. For my intercepts, the only time I see it cross an axis is the x-axis, where we found was 1. So we have an intercept of, let's see, x equals 1. And asymptotes, like I said, we appear to have an asymptote where x is equal to 0. The end behavior, as I go to the left, my function approaches negative infinity. And when I go to the right, it seems to like it's eventually going to approach positive infinity. So let me write that. The limit as x approaches negative infinity appears to be negative infinity. The limit as x approaches positive infinity appears to be positive infinity. And then I'm increasing on the interval of 0 to infinity. And let me just actually correct myself here. I said the limit as x approaches negative infinity. X actually to the left is never going to approach negative infinity. So technically I should write as x approaches 0. Sorry about that. So now this example we have g of x, which we want to graph. The logarithm with the base of 1/3 of x. And this time I'm going to show you how to use a calculator. You could, of course, do what we did last time and find 1/3 to all sorts of powers and then graph the inverse. But there is a way to do it on the calculator. You just have to be a little clever about it. So what we can do is go into our y equals, clear this out, and we can put log of x over log of our base, which in this case is 1/3. And we should obtain the graph of our function. So I'll zoom standard, and it looks something like that. So as we're describing this, its domain, I was really hoping that would stay up there, but the domain appears to be from 0 to infinity. Well, the range appears to go from negative infinity all the way up to positive infinity, because it seems that it would go down, although much less and less so. Eventually it'll go all the way down, and then coming this way, this graph goes up to positive infinity. Now the intercepts, it appears we have one intercept there. So let's take a look at how we can actually figure out the exact value of that 0. If you go to second calc on your calculator and then go down to this number 2, calculate the 0, what it's going to ask you for is the left bound. So you can come over here somewhere to the left of where you think it crosses and hit enter. And then make sure you go over to the right of where it crosses for the right bound and hit enter. And then it's going to tell you to guess. So what you do is you bring it over and give it your best guess of where it crosses the axis, x-axis, and hit enter. And then it calculates it for you that there's a 0 at the point 1, 0. So that tells me that I have an x-intercept at x equals 1. I have an asymptote here clearly at the line y equals 0. Asymptote. And then I have end behavior. It looks like as to the left as x approaches 0. My function goes up to positive infinity, and my limit as x approaches infinity to the right, it appears it's going down to negative infinity. And where the function is increasing or decreasing, well, it's never increasing, but it's always decreasing. Sorry, always decreasing from 0 to infinity. So there's your qualities of that graph. Let's go ahead and take a look at an example question. See if you can describe the end behavior of the function f of x equals log base 4 of x.